All right, it looks like we are in great shape then. So let's go. Here we go. And can you all see this? I'll wait for a bing. Wait, I better make sure. Is that a good one? Yes. Okay, cool. So look at this. See, I'm hiding in the bottom corner. Look at all the work I put into getting this set up nicely for everybody. All right, so I suppose we'll jump into this thing here. So of course, this is programming in data structures. My name is Dr. Hughes, James Hughes. It's my email. There's my office in the annex, although office hours aren't really happening in person. Office hours are, as of now, they are set to be Tuesday, Wednesday, Thursday, Friday, 10 to 11 a.m. The main focus of this class is the organization and manipulation of data, and making choice about how best to store and organize our data. And for the most part, we're going to be talking about linear data structures. And that's just a fancy way of saying data that's held in a way where there's like a logical next one, like what comes first and then what's next and what's next. And then you can have nonlinear data structures which are a little bit more complex and interesting, powerful. Again, for lack of a better term, I'm saying powerful. And they're a little harder to work with. And we will talk a little bit about these as we get to the end of the course. But really the focus here is on linear data structures, namely stacks, queues, and lists. Lists are just the lists you've been using in Python, assuming you took 161 with me. They are lists. You're already familiar with them. But chances are you're not familiar with how they're built. Chances are you've hopped in the car, that is lists, and you've used it. It worked for you great, fantastic. But you don't really know what's going on under the hood. In this class, we're going to talk about and learn about what's going on under the hood. And it's really interesting. It's really fun. I think so, at least. Oh, also, I should give you a warning that there's currently quite a bit of construction going on in my house. So if you hear a lot of funny noises in the background, try to ignore them. Hopefully it's not too disruptive. So a stack. Stack is exactly what we're talking about, a stack. And actually, raise your hand if you remember learning about the system stack. I talked about, I think, a little bit in 161. Raise your hand if you kind of remember that. I want to see if I get a little bit. Okay, so yeah, a couple of people are saying they remember. Okie dokie. So that's good. And you know what? I better check my CPU usage. It's a little high, but hopefully we're surviving. Type in the chat if it ever gets really bad, and maybe I'll lower the resolution or something. Is it bad if we don't know what a stack is? No, because I'm teaching you what a stack is, so don't worry. But, I mean, the reality is chances are you actually do know what a stack is, just not one implemented in a computer. Is like, you ever been to a buffet where, you know, they've got that stack of plates, right? You've all seen that type of stuff, right? Like I could, you know what I mean. Let me, let's see, buffet stack of plates. Let's see. See, you know these things, right? Well, actually, that's not what I'm looking for. Let's see. I want to find a better image. Well, this is less interesting than I was. These ones. You know these things, these dish dispenser things. You know, you put the plates on top. You know, the bus person comes out with all the new plates and they put them on top, right? And then you, as someone who's eating at the buffet, you're going to grab a plate. But where are you going to grab the plate from? At the top, obviously. You're not going to go. You're not going to grab a plate from the bottom or somewhere in the middle of the stack. You grab from the top. So all the action in a stack happens at one end. You add things to a stack at the top, and you take things off the stack from the top. That's it. Then we've got queues. I mean, chances are all of you have been in a line at one point in time in your life. Chances are maybe you went to the grocery store, you had to stand in line. Maybe you went to Tim Hortons or something, you were standing in line. You're getting your coffee. You're familiar with this. When you enter a line or a queue, you enter at the end of the queue, and the people leaving the line, the person that's next to be served, leaves from the front of the queue. And if you're all following the rules of lining up well, then this is how it works. You don't cut in a line because that's not very nice. That's breaking the rules, right? So a queue is just this. Now I say stack and I say queue. These are real things that we're familiar with. These are real world ideas or objects or things, whatever. But we're going to implement these ideas in a computer to store data. And we will access and put data on a stack only at one end. And a queue will put things at the end and remove them from the front. That's how it works with a queue. A list of numbers. All right, so, I mean, we can have lists of whatever type we want. And this is an example of a very specific type of list. It's an ordered list. So the rule with this list, and by the way, I'm just showing you one example of many different types of specific types of lists. This is an ordered list. And whenever we add things to this list, like if we're trying to add the number 58, obviously it goes between 51 and 67. I mean, we know that. But unlike the stack and the queue, where things were happening at like the ends, these lists, we can do it wherever we want. And the rule with this data structure is the stuff needs to be ordered. So I can't put 58 here because, I mean, 58's bigger than 16. 58's bigger than 23, bigger than 29, bigger than 40, bigger than 51, less than 67. So I know it must be here, right? I know it must be between. Also, can you see my mouse when I'm moving it around? Say in the chat if you can. Again, this is the first time I've done it this way, so let me know if, yes, you can. Okie dokie, good stuff. Notice that, like, when I did that linear search here, and you should all remember this is a linear search. When I asked the question, okay, is it bigger than 51? Is 58 bigger than 51? The answer was no, right? It's not. Then I go, no, I said that wrong. Scratch that. Is it less than 51? No. So if it's not less than 51, it is greater than or equal to 51, right? So I know 58 has to come after it. And then I go here and I look at 67. And I go, 58's less than 67. So it must go before 67. And I just established that it must come after 51, right? So I know it goes right there. So I'm happy. Yay. Anyways, that's not the point of this lecture at this point. So we're going to talk about data structures. And we're going to be focused on linear data structures a lot. And sometimes we call, this is a typo in the slide, sometimes we call the data structures collections or abstract data types. But a big part of this class is focusing on these data structures, these collections of information. There's going to be the algorithms as well. They kind of go hand in hand. But there is a big emphasis on the data structures because they're important to know for your future in programming computer science. Also, to be very clear, do please raise your hands when a question comes up. I'll listen for the boops and I will stop and answer your question as best I can, given the circumstances. So things that we're going to learn. We're going to talk about references, pointers, and dynamic memory. This is true in general in computers, but this is going to be really important for C++. Things you didn't really need to think about too much with Python. We're going to talk about classes, stuff we learned in Python already last semester. We're going to learn about stacks and queues. We're going to learn about linked structures and then lists. We're going to talk a little bit about inheritance, what templates are. We're going to do a little bit of analysis of algorithms. You might remember from 161 when I was doing things like, okay, if there's a linear search, how many things do we have to put our finger on if that list is size n? Well, we kind of got to look, worst case scenario, we got to put our finger on all n things. That's kind of like analysis of algorithms. We got binary trees. We're going to talk about sorting algorithms, and we're going to do a little recursion as well. And this list is not exhaustive. We'll get to as much as we can, and we're probably going to cover a little bit more of this, a little more stuff than just this, but to give you a sense of where we're going. And at any point, if you're looking at this stuff and you're thinking, I don't know any of this stuff, that's fine. That's fine. We're going to learn it all. All right, so we're going to be using C++. Yay. But it's not a direct learning objective of the course. Like I was talking about a little bit before we started class, it's about data structures and algorithms and good programming practices. C++ is the tool we're using to learn all this stuff. So we'll be learning C++, but I'm not really teaching you C++. I'm teaching you the other more important stuff. Because these ideas are much bigger than just C++ itself, because that's just a programming language. Okay, don't panic though. You'll see really quickly that you already know a lot of the important stuff you got to know in order to program in C++. The design of the code is effectively the same. It's just you got to learn the differences in syntax and a couple of little different rules. And C++ can be a little picky, and there's going to be a lot of C++ isms that are going to get in your way. But but you'll figure them out pretty quickly. Because if you're thinking of an algorithm, because you should be thinking of an algorithm kind of independently of your programming language at this stage. So if you're thinking of an algorithm like, I know how to write this in Python. First, I'm going to have like an if statement, and there's going to be a loop in it, and then I'm going to have these variables to store on this information. How do I do that in C++? Well, that's easy. Go to Google and type in loop C++. Boom, you'll find a billion examples. Or if statement C++. You'll find another billion examples. So you're in great shape. C++. Officially, we're using Visual Studio. So that's great news for Windows users and not great news for Mac users. Unofficially, you can use whatever IDE you want with at least C++11. So if you're using Mac, I know in the past people have gotten away with Xcode, although I know it can be tedious, but don't ask me a single thing about Xcode. I don't know anything about it. People have used code blocks. People can do just basic command line stuff for all I care. Unofficially, I don't really care, but the only one that's going to be the one that's really the one that we're using is Visual Studio. If you're a little worried, like if you have a Mac and you're a little worried about like, oh no, I want to use Visual Studio, everyone else is using Visual Studio. The good news is that the virtual lab environment that SaintFX has set up has Visual Studio on it. So you could actually use it there. So you connect to it and you're in good shape. However, you submit the code must work on the lab computers. Well, that's easy to do. Just test it. This guarantees that we can actually mark your assignments. If you do not ensure this, we might be unable to mark your assignment. If this happens, you will get 0. No accommodations will be given. Okay, should you be here? Well, if you've got 161, 125, or engineering 147, or have some other override, you're in great shape. If you don't have these things and you're here, something's gone funny, and you should probably email me and we can figure this out. Okay. This is the textbook officially. I've worded it such that this is the recommended textbook. It's not necessary. It's not going to be a really big... It's not going to impede you if you don't have it because it's C++. You can find everything you want to know about C++ on the internet. But this textbook, it is nice to have like a nice, compact, curated book that contains all the stuff you got to know. So your call if you buy it or not, but this is the textbook we're using for the course. I also do deviate from the textbook in a number of places as well, though, so just FYI. Course website. Well, Moodle will have everything. I'm going to post the lecture slides. If you've accessed the Moodle site, which I assume you have, considering you're here right now, the lecture slides are there for like the whole semester. Do note, though, that they're subject to change, because I've already even changed this lecture. Lab instructions are there, again, subject to change. Assignments will be there. Assignment 1's already posted, if you haven't noticed already. Links to things that I think are cool may or may not be there, and sample code when I'm feeling nice will be there as well. A lot of it's already up there. Check it frequently as I'll update Moodle when I feel like it. Apparently that's what I wrote in this slide. There will be lecture slides will be made available on Moodle, and they are there to help, and are provided by me because I'm a nice person. They are not a substitute for attending the lecture. The lecture slides, I talk about so much more than just what's in the slides. And so many times I'll be talking about, like I'll be showing you code. Like I'll be like, look over here, I've got, oh, we don't need the stack of plates anymore. Like I'll be using Visual Studio and I'm gonna show you some of the code, right? So you'll gain so much more from the lectures. I saw a question in the chat. Let's have a quick look here. If it'll ever change. So there's no separate website. No, there is no website. I've dreamed about making a website for the course, like 161 for this course, but there's just not quite enough time to get that arranged lately. I'm actually also teaching an overload this semester due to funny circumstances. Raise your hand if you're actually taking 215 with me this year. Or if you're taking 215 and didn't know I was teaching it because it's changed suddenly. 1, 2, 3, a couple people. Cool. So I'm teaching overload now. Okay. Attendance is technically mandatory at SaintFX. Students missing 3 classes will be reported. You will be reported if you're repeatedly delinquent in assignments or attendance at class laboratories. Okay. Copyright policy. I or the textbook publisher owns everything here, okay? And I'm not only reserving the right, I'm exercising my right of I own it all. And you cannot disseminate, you cannot do anything with with what I've got here unless I give you explicit instruction to. Don't worry, this isn't going to be a problem. In fact, I'm recording these lectures that will be posted on YouTube. So I'm making this stuff very, very, very available, but I'm in control of it. So FYI, these lectures are being recorded and will be posted on my YouTube channel, which you can find a link to on the Moodle website. Just like the lecture slides, the lecture recordings, although obviously a pure recording of what's going on in the lecture, you still gotta attend lecture because you'll learn so much. Like, you'll be able to ask questions. It's more engaging. You can participate, and technically you have to at St. FX. Mark breakdown. This is one of the things that I had to change this morning from the slides that I originally had up. Labs, 10% of your final mark. Lecture activities, they're not happening. Like, formal lecture activities aren't happening this year because of COVID-19 rules. We'll have 4 assignments, 10% each. There's no midterm, and the final is worth 50% of our final grade. That's a lot, I know, but it is. Assignments, they'll be posted to Moodle. Submission details will be posted there. I don't accept late assignments. It's either in on time or it's getting a 0. That's it. They're marked by TAs. You officially have a 2-week window to request a remark, and always keep everything backed up, because if suddenly your hard drive crashes and you don't have access to your assignments, well, you're in big trouble. So always back up your stuff. Labs, 10% of your final grade, 2 hours per week. Labs start this week. It will be online, I guess. We'll figure it out somehow. Tomorrow, if you're in tomorrow's lab. Yes, this week. Completing specific portions of the lab are required in order to receive full marks. Lab instructions will be posted to Moodle. Yeah, each lab is worth 1% of your final grade up to a maximum of 10. So, like, if we have 12 labs, it's your best 10 out of 12. For example, lecture activities, we're just ignoring this. Academic integrity, assignments are to be completed individually. Discussing high-level ideas with others is actually a good thing. Peer teaching, peer learning, but working on assignments together is not. Collaboration that results in assignments that are more than coincidentally alike will be regarded as cheating, and all your stuff will be subject to, like, code similarity and plagiarism detection stuff. It's your responsibility to understand what academic misconduct is. It's not my role to teach you. It's your role to understand it. The good news, though, is the rules for cheating have been the same since you were, like, in grade 1, so you don't need to really learn anything new. And I always advocate for the most severe punishment for cheaters because I have no patience for you. I find it very disrespectful to me, the university, your peers, everyone who's ever taken this course, everyone who will ever take this course, and really just higher education in Canada or the world. No patience for cheating. I don't sympathize. People who are really sad after, it's because they got caught. So just don't cheat. It's simple. It's really easy to not cheat. I caught a couple people last semester. It makes my day when I catch cheaters. Email contact, emails from me to you, St. FX email address, check later. Emails from you, St. FX email. Put 162 in the subject line. I've already received a bunch of emails from students being like, I'm in your course, blah, 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 blah. And I'm like, well, I don't know what course you're in. I have no idea. So make it clear for me. And email questions, they got to be high-level questions. If I get emails with chunks of code and they're like, what's wrong with this? Each one of those take ages to respond to. That's not workable in email. Those are office hour type questions. So if you have a high-level question, email's fine. Use email. I want you to use email. Otherwise, it's an office hours type thing. Come to office hours. Office hours were hilariously poorly attended last semester. Come to office hours. Read the syllabus. There was somebody yesterday, I had a good laugh. Somebody yesterday emailed me, I don't remember who it was, I deleted the email, about like, what programming environment are we using? And I responded with like, there's like a meme for professors about like, oh, read the syllabus, you know? And for the first time, I actually responded to the student, like, read the syllabus, come on. And then they responded to me saying, I did, this information wasn't in the syllabus. And I was like, damn it. So the first time I used that meme, I got burned on it. So if that was you, well, congratulations, you got me. And that's it for this. So there's that. So I think there's some other things in the syllabus that I kind of want to hit. Typically I don't specifically go over a syllabus when starting a course, but because things are funny this year, I'm going to do that. Yeah, blah, 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 textbooks, notes, course website, yeah, Moodle, labs, great. Is that right? January? Yes, tomorrow. Assignments, yeah, assignment due dates, marking, the final exam will be take home, like last semester. I'll figure it out. It's effectively just like, kind of like an assignment. I like to design my exams where if you know what you're doing, it should be easy. If you don't, it should be very hard. That's what I want my exams to be like. The mark breakdown, email contact, and I hear a question.
Just to clarify, the take-home exam won't be on pencil and paper, right? It'll be like we'll be allowed to write in the software.
Yeah, that remains to be determined. It is very, very, very likely that you will like be coding and then submitting stuff. So does that answer your question good?
Yeah.
Cool. Email, attendance, copyright statement, use event, tutoring statement, blah, 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 class recovery. Okay, cool. All right. Okay, Python versus C++. This is where we're going to start. So the last set of slides was really just prep stuff, just so you kind of know what's going on. Are there any questions about anything before we get going? Obviously, the first 2 weeks of the course are now, I guess really it's only a week and a half, are online. So in-person classes start whenever they start. It'll be in person until it's not, if that happens, Let's see, I think I hear boops. Are there questions? Please ask questions now, though. No. All right. Do we have labs this week? Yes, we do. And I think I remember you asking me that last semester and saying, yes, they start the first week. And you were like, come on. But yes, they do, because we got a lot to cover, for better or worse. Any other questions before we get going? Yes, just checking. Yeah. Like I was saying before, the lecture will be recorded and submitted to Python for your review later. Okay, Python. Oh, another boop. Is there a good C++ software for Chrome OS? Ooh, not that I know of. I'm going to, on your Chrome OS, do you have decent access to the lab virtual environment stuff they use? It's like Microsoft Azure or something? I haven't tried. Well, definitely try that, because that's going to be your big, that's probably the best way to go about doing it. I can guarantee you there is absolutely C++ environments for Chrome OS. I don't know any. Pretty sure CodeBlocks works on everything. Okay, so there's an option. But I do stress that if you can, Visual Studio, it's free for students. You're going to really like, there you go. Okay, that's great. That's really good. Works on Chrome. The virtual Microsoft app works on Chrome. Okay, this is all really good news then. This is fantastic. Look at this. Look how great of a group of students we've got. Look how helpful and constructive we all are. This is going to be a wonderful semester. So if you can, I do recommend Visual Studio, though, because there are a lot of like perks that come with it. So before anything, actually, how about this? I'm going to create a new project. These don't exist anymore. I just deleted them because I was just testing. I'm going to create a new project, empty project. Yeah. And we're going to call it Class 1, because why not? And we're going to do Hello World. Just so you can see Hello World. See how well Visual Studio holds up. It is a bit of a beast, and how How obnoxious is that noise in the background? Is it really bad or not too bad? No, not terrible. Okay, okay, all right. What do we got? Nah, I just noticed it now. Okay, bearable. Okay. Not horrible. Okay, okay, good. All right. Oh, where did Visual Studio go? All right. Okay. What's everyone saying? I can't see anything. I'm gonna try and reconnect again. Okay. Any text besides big headers is unreadable. Oh. Okay. Maybe. So you can't really see this, eh? I'll have to figure that one out. But anyways, I've created a new empty project on Visual Studio. I'm gonna right click the class. I'm just gonna make sure, what is this? Yeah, it's like 240p, but it jumps around. Ew. Well, all right. Here's the recordings will be in HD. That'll be on YouTube. A lot of the code will be in the slides though too. But I'll see what I can do about seeing if I can like zoom in or whatnot. I'll be able to zoom in on the code, so you'll be able to see it, but a lot of the text in the IDE you won't be able to see very well. But let's see how it goes today. So I'm in Visual Studio. Every IDE is going to be a little bit different, but I've got here, I'm going to right click on the name of my project. I've called it like class 1, right click, go over add, new item, and I don't know. Hello world, great. We always need to do hello world, right? Okay, so if this was Python and you're doing hello world, you do this. Right? Done, right? C++, there's a little bit more. First thing we got to do is import. Is it import or include? I guess it's import. No. Include? I always forget. Include. There. Look at that. Look how helpful you are. This is amazing. Okay. Yes, I can zoom in a little bit. Include IO stream. There we go. And there. Now we've got unexpected file name. What? Okay. So now we've just imported the thing that lets us like print stuff. So in Python, it was imported by default whenever you loaded it up. In C++, you got to say, well, okay, we're actually going to be doing some like IO stuff. Okay. Next, we always need a main function. In Python, you didn't need one because it kind of like did that for you. But in many other of the big programming languages, you need a main function. So int main, great. So that's it, we're set up. Now I can write the equivalent of print hello world in C++. So I'm gonna say std : cout less than hello world less than std : and L. Now I'm going to build this project. I use the hotkey, which is Control-Shift-B. It'll take a second to build, especially the first time you build a project. And we can see all the fancy dialogue coming up here that I'm guessing you can't really read. Succeeded, okay, and then run it. Control F5, I think is what I pressed. And let's see what happens. Hello world, and I'm guessing you can't really see this, but it says hello world. Yay, it worked, great. Now, if you've never seen C++ before, you're probably looking at this going like, wait, what? Like, I mean, Python, it said print hello world. What's going on here? std : that's C out, not count. Less than, what's going on here? Well, there's a lot. But that's hello world. All right, I'm gonna go here and let's go. let's start this. The point of this lecture is to see some of the pros and cons of Python versus C++, review kind of the really big important concept from 161, and we'll see them in C++ and Python just to kind of see the comparison, and see how to do what we already know in C++. Really, that should be like what we already know in Python, but in C++. So why did we learn Python on 161? Well, Python is a wildly popular programming language, and it's getting more and more popular by the day. I use it so frequently now from the work I do, just because it's so easy to use. It makes it very easy to learn programming concepts. There's some arguments within like the computer science pedagogy community, but I'm firmly on the point of computer science is you're learning, when you first learn, is how coding works, variables, types, functions, ifs, loops, and whatnot. That's the important part. Things like, well, the syntax and this, that, and the other, they're not really as important. They're secondary. They're important, but they're like the secondary things compared to learning the ifs, and all that stuff, the algorithms. And see, Python is really great because it eliminates a lot of some of like the more frustrating issues that come with a lot of the other programming languages. So, I mean, in Hello World, right? Like in that example, I mean, Hello World in Python is print Hello World. Look at all this stuff. One line versus 1, 2, 3, like 4, like what's going on there? Why are we moving to C++? Well, you get to learn another programming language. This is always a good thing for a number of reasons. It's always good to get experience with another programming language, but it's also good to see the differences between programming languages and the similarities, because it gives you more context of what's important and what's specific to a programming language. It's very popular. In fact, if I click this link, I think it'll work. Aha. Let's see. This is up to date. This will tell us which programming languages are the most popular. January 2021. I'll zoom in for you. Okay, let's see. Let's go down to the list. So C, C++ are there. Okay, I mean, especially for what we're doing in the early stuff, the distinction between C, C++ is not huge for the early stuff. But you'll see like, these are like all the very popular programming languages. You'll see Python remarkably popular. Java is also a really popular one. C, C++ also very popular. C#, which might sound like it should be similar to C, but it's actually a lot similar to Java in my opinion. But these are all really big popular programming languages. So it's going to be good for you to get a chance to see them all. C++ is a lot faster to run on your computer than like Python. And C++ does give you a good chance to see a little bit more under the hood of how these computers work. And you can't see, but I'm hitting my laptop. And it also gives you more freedom to do things how you want. But of course, like what the saying is, you know, we give you a lot more rope with C++. There's a lot more freedom. You got a lot more rope. But of course, it gives you a lot more rope to hang yourself with. So pros and cons to that. Do we have to change? Yes. First, interpreted versus compiled. Actually, before that, any questions so far? And at any point, just type something in the chat, because I can hear the boops and I can stop and answer them. But if you have any questions, ask them now, because I'm still just kind of giving context to the course. Well, here we go. Just wondering about Visual Studio. What about it? Or is that just a big broad thing you're thinking? What packages to download? Oh, when you do it. I can't remember off the top of my head, but there's one for like C++. You don't really need a lot of the extra bells and whistles. In fact, I'd recommend not getting all the extra bells and whistles, but there is one of the packages you have to select for like doing actual C++ development. I don't remember off the top of my head, but I'm sure it might make it clear in the installation guide, or maybe you can find something online. The one with C++ in the title. Yes, that's probably the case. I think Microsoft makes a specific C++. Yeah, it does. I'm pretty sure, and I mean, it's been a while, and I could be wrong, but I'm pretty sure you go back a couple of years, back when I was doing my undergrad, when you'd install Visual Studio, like you didn't need to specifically select C, C++. It kind of like came by default, but now you absolutely do need to specify it. But I could be wrong. Maybe back then you had to specify it. I can't quite remember. Do note, don't get Visual Studio Code. Get Visual Studio. Visual Studio Code is not going to be particularly helpful. Visual Studio is. It's a behemoth. Does Visual Studio work on Windows Boot Camp fine? I don't know what Boot Camp is for Mac OS. I don't know what that is. You can give it a go and let us know, though, because that would be good to know for other Mac users in the course. Keep asking the questions away. If I hear a boop, I'll come over, but otherwise I'll carry on. Another boop. Hackintosh. Yeah, good luck. Okay, first, interpreted versus compiled. So Python is an interpreted language. Scripts run in an interpreter, which is a special programming running on your computer that runs the scripts. So it's kind of like a middleman, right? So the program isn't running like directly on your computer's processor. It's running in this program that runs on that processor. It might sound like, wait, is that nuance really important? And I guess at this stage, maybe it doesn't matter too much for you, but it is an interesting difference nonetheless. What else we got here? Just as well as anything else works on Boot Camp. Okay, sounds about right. All right. C++ is a compiled language. So we compile codes into programs that run directly on our computer. It's pretty cool, actually. Like, what will happen is your C++ code will turn into, like, when you compile it, it will turn it into like zeros and ones that actually run through your processor. Where the interpreted stuff, it doesn't quite work like that. So like it cuts out the middleman, but a lot of this is very language specific. So Python's hello world, like we were talking about, there it is. Pretty straightforward, right? C++, what do we see? Well, we see this. And what's different? Well, everything looks pretty different. So let's zoom in. Let's have a look. We see, okay, include IO stream. Well, like we were saying, it's basically the imports like we saw in Python, but Python for free, we were able to print stuff out. In C++, you got to say like, well, okay, include IO stream, so now I can print stuff out. Okay, great. What else we got? We've got main. See how I've like made bigger here. Main, it's just a function. In C++ and many other of the big programming languages, we need a main function. It's like when you hit run on a program, the main method, or like the main function, is where it goes. So like when I make this program, and let's say I were to go like, I were to run it, the computer goes and looks for like that main method or that main function to look to where to start running. Int is the return type of a function, and we're going to talk a little bit more about this later. Hello world, that's just a string. We're printing it out. Mind the double quotes, though. You might remember back in C++ we had, you could use double quotes or single quotes. In Python we could use double quotes or single quotes, but in C++ we got to use double quotes because a single quote means a character, which is this very special specific type, and it's completely different from a string. And also, every statement we make in C++ has to end with a semicolon, where in Python you didn't need to do that. Sometimes, though, you might say, like, well, there's no semicolon after int main, and you're right, but you'll just get used to figuring out when and where you need semicolons. You'll see a bunch of examples as we go through these slides, which will be ending very shortly today. But you'll see a bunch of examples where you see semicolons. Kind of get a sense of what's a statement and what's not. Hello world, yeah. This, yep. Okay, std cout. This one's weird. So ignoring the std for a second, cout is like the thing that we say. It's kind of like the print. Okay, cout, that's like, okay, print this. And the std : that's like the namespace from where that print is. So do you remember in Python how we would like include math, and then you would have to say like math dot sign or something? Well, this is kind of like that. It's like from the standard library, cout. So instead of a dot, we use 2 colons here. Okay. That's like pumping things into it. You might say, well, if it's a function, why don't we have round brackets? Well, because C++ is weird. We do it this way. So what are we couting? Well, this stuff here, and just pump it through. And then std, same idea. It's like from the standard library, end L. This says like, okay, end of the line. It flushes the stream and it'll get printed out. And we're going to pump that into the cout as well. That's all. And L, great. Now we've got these squiggly brackets. In Python, we didn't need them. But if we go here, you see these squiggly brackets. They don't really matter where I put them, I guess, as long as like the relative location stays the same. But remember how like in Python knew what was inside a function based on indentation? C++ is not like that. Python knows what's inside a function based on the squiggly brackets. In fact, indentation doesn't matter at all. I can do this. Build it. It's building. Run it. And it doesn't matter. It's going to be happy. In fact, I can do like this. This is absurd, right? But I'm going to build it, and C++ isn't going to care. It's like, yeah, okay, fine. As long as this and this, I'm happy. I'm in great shape. Let's see. Just so, yeah, see? It's happy. Squigglies, yeah, okay, great. Okay, so we'll end here, and we'll pick up here on Friday, I suppose. For those of you that have lab tomorrow, you'll be thrown in the deep end a little bit, but we'll get it figured out. And it'll be more of an exercise of learning. Those that have lab on Friday will have seen a little bit more of this stuff in lecture, but it'll be fine in the end anyways. So that's that. If you have any questions, of course, shoot me an email. And yeah, okie dokie. Otherwise, I'll see you on Friday or Thursday afternoon. Okay, goodbye.